Hi students, welcome to my YouTube channel. After long gap, I'm going to make YouTube videos. So first I would like to start the chapter inverse trigonometric functions. So in this chapter we are going to study the first exercise. That is what exercise 2.1. So in this chapter he has given that what find the principal values of the following inverse trigonometric functions. So first question, the principal value of sin inverse minus 1 by 2. So to identify the principal value of sin inverse minus 1 by 2, we know that the property. What is that? Sin inverse of sin x is equals to x. For what? X belongs to closed with minus pi by 2 to plus pi by 2. This is what principal value branch of the sin inverse is. Here the first question is principal value of sin inverse minus 1 by 2. So to identify this, we know that the value of sin pi by 6 is equals to 1 by 2. It means if the sign towards the right side, that is what sin inverse of 1 by 2 is equals to pi by 6. Therefore, this can be written as sin inverse of minus at 1 by 2, we can write it as a pi by 6. Means sin pi by 6. And also we know that one more formula, that is what which is stated in the first place, sin of minus theta is equals to minus sin theta. So it means this can be written as sin inverse of sin of minus pi by 6. Now if you observe here, this angle minus pi by 6 is belongs to the interval, is belongs to the interval closed with minus pi by 2 to plus pi by 2. Therefore, sin inverse of sin x is equals to x. What is x again? Minus pi by 6. So, minus pi by 6 is the principal value of sin inverse minus 1 by 2. Now, let us start the second question. Find the principal value of cos inverse root 3 by 2. Cos inverse of root 3 by 2. So to solve this, we know that the properties of inverse trigonometric function. What is that? Cos inverse of cos x is equals to x. For x belongs to closed with 0 to pi, which is what principal value branch of cos inverse x. Therefore, this can be written as, so as you know that the value of cos pi by 6 is equals to root 3 by 2, or pi by 6 is equals to cos inverse of root 3 by 2. So directly we can write it is equal to what? Pi by 6, or in other words, this can also be solved using the property, that is what cos inverse of root 3 by 2 can be written as what? Cos pi by 6, cos pi by 6. Now it is also from cos inverse of cos x. What is x? X is pi by 6. So pi by 6 belongs to 0 to pi. 30 degrees less than 180 degrees. Therefore, cos inverse of cos pi by 6 is equals to pi by 6. So principal value of cos inverse root 3 by 2 is pi by 6. Now, let us know the third question. What is the third question here? Here we need to find the principal value of the cosecant inverse 2. So third question, cosecant inverse of 2. Again we know that cosecant of 5 by 6 is equal to 2. It means 5 by 6 is equal to what? Cosecant inverse of 2. So simply this can be done as 5 by 6, or we know that, what is that? Cosecant inverse of cosecant x is equals to x for what? X belongs to principal value branch of cosecant inverse x. What is the principal value branch of cosecant inverse x? Closed with minus pi by 2 to plus pi by 2 except 0. So now this cosecant inverse of 2 can be written as cosecant inverse of cosecant 5 by 6. So now cosecant 5 by 6. So now it is out of cosecant inverse of cosecant x. What is x? X is 5 by 6. Therefore, this can be written as cosecant inverse of cosecant 5 by 6 equals to 5 by 6. Why? Because 5 by 6 is belongs to what? Principal value branch of cosecant inverse x. Now let us go for the fourth question. What is the fourth question here? The fourth question is find the principal value of tan inverse of minus 1. This can also be solved with two methods. First thing, we know that the property of the inverse trigonometric function, that is what? Tan inverse of minus x is equal to minus tan inverse x. Therefore, tan inverse of minus root 3 can be written as tan inverse of root 3. Tan inverse of root 3. We know that the value of tan 5 by 3 is root 3. Tan 5 by 3 is root 3. Therefore, since this tan towards right side, it becomes what? Tan inverse of root 3 is equal to 5 by 3. Therefore, this can be written as minus of 5 by 3. Or we know that one of the property, tan inverse of tan x is equal to x, or x belongs to principal value branch of tan inverse x. What is principal value branch of tan inverse x? Open with minus pi by 2 to plus pi by 2. Therefore, this tan inverse of minus root 3 can be written as tan inverse of minus root 3 can be written as tan pi by 3. We know that tan of minus theta is equal to tan of minus theta is equal to minus tan theta. Conditions of negative angles of the trigonometric functions, which is studied in first division. Therefore, this can be written as tan inverse of minus tan pi by 3 can be written as tan of minus pi by 2. Now it is also for tan inverse of tan x. What is x? Minus pi by 2. Observe here, minus pi by 3 belongs to open with minus pi by 2 to plus pi by 2. Because minus 16 in the interval minus 90 to plus 90. Therefore, this is equal to what? Minus pi by 3. So I hope all of you understand. Let us start the fifth question. What is the fifth question here? Here the fifth question is principal value of cos inverse of minus 1 by 2. To identify the principal value of cos inverse minus 1 by 2, again we know one of the property of inverse trigonometric function. That is what cos inverse of minus x is equal to y minus cos inverse x. Therefore, this can be written as cos inverse of minus 1 by 2 is equal to pi minus of cos inverse 1 by 2. So this is equal to pi minus. We know that cos pi by 3 is equal to 1 by 2. It means cos inverse of 1 by 2 is equal to pi by 3. Therefore, cos inverse of 1 by 2 is equal to 1 pi by 3. Now taking LCM, 3 pi minus pi divided by 3 which is equal to 1, 2 pi by 3. Or this can also solve by using one more property of the inverse trigonometric function. That is what we know that cos inverse of cos x is equal to x for x belongs to 0 to pi. So to identify this, the cos inverse of minus 1 by 2 can be written as cos inverse of minus 1 by 2 can be written as pi minus cos inverse of 1 by 2. This is equal to pi minus cos inverse of 1 by 2 can be written as cos pi by 3. Again, this pi by 3 belongs to this pi by 3 belongs to what? Closer with 0 to pi. So therefore, pi minus cos inverse of cos x is equal to x. Already we know that pi minus pi by 3 is equal to what? 2 pi by 3. I hope all of you understood. So now last question, what? Tan inverse of minus 1. We need to identify the principal value of tan inverse minus 1. We know that, again this also can be solved in two different ways. What is the first one? Tan inverse of minus 1. We know that tan inverse of minus x is equal to minus tan inverse x. So therefore, tan inverse of minus 1 is equal to minus tan inverse 1. This is equal to, we know that tan pi by 4 is equal to 1. Tan pi by 4 is equal to 1. Or pi by 4 is equal to tan inverse of 1. Therefore, this can be written as minus pi by 4. So minus pi by 4 is the principal value branch of tan inverse minus 1. Or this can also be solved in second method. What is that? So tan inverse of minus 1 can be written as tan inverse of minus. In place of 1, we can write it as tan pi by 4. We can write it as tan pi by 4. Again, we know that conditions of negative angles. Tan of minus theta is equal to minus tan theta. Tan of minus theta is equal to minus tan theta. Therefore, this can be written as tan inverse of tan of minus pi by 4. We know that tan inverse of tan x is equal to x for x belongs to principal value branch of tan inverse. What is that? Open with minus pi by 2 to plus pi. Definitely minus 45 is inside the minus pi by 2 to plus pi by 2. Therefore, this is equals to what? Minus pi by 2. So it means you may solve by using any of the method, but you will get the same principal value for tan inverse minus 1. I hope all of you